All right, so let's take a look at this water vascular system that we have in echinoderms. So we're looking at this in a sea star, but again, you would find this in all of the echinoderm groups that we'll talk about going forward. But the sea star one's kind of pretty easy to see and understand, so we'll look at that first. So first, on top, we have what's called the madreporite. This is where the water is sucked into their bodies, into the water vascular system. So it's kind of the little intake for water. So water gets sucked in here. Then there's this central ring canal. So the water is inside this ring canal. It can then go into the radial canals that are in each arm here. And then there are these little things called ampulla that are basically kind of like little water balloons or that you can kind of squeeze. And attached to each of them is a tube foot. So these are the tube feet of a sea star, and basically they can pump water into them in order to extend the tube foot, and they can pump water out of them to like withdraw the tube foot. And they use these to walk and manipulate things and do all kinds of stuff with their little tube feet. So that is this water vascular system. They're essentially using hydraulics, like water pressure, in order to control the movement of their feet and a lot of other parts of their body as well. Now, one of the reasons this can be kind of advantageous to move your body using water pressure instead of using a lot of like muscular power is you basically can kind of set and forget your tube feet. So let's explain what I mean by that. So sea stars love to eat things like clams and mussels. And what they'll use, but of course, clams and mussels don't want to get eaten. So they will close the two halves of their shells, and then they will hold those shells closed using their adductor muscles. So these little muscles that will prevent those two halves of the shell from being pulled apart. So they're holding on tight with those muscles. But all muscles eventually get tired, right? But the sea star can attach its 2 feet from the side to either side of like a muscle. Then it can kind of pump the water to create a pressure differential so that it's pulling on either side of the shell. So again, just by creating the pressure difference. And then it just has to wait because it pumps the water to where it needs to be. And now it's, yeah, just waits. And eventually, again, that muscle will get tired. And so it'll open just a little bit. And that's when the sea star can then eat the clam or mussel. So that's kind of one of the advantages of this water vascular system is you can use water pressure instead of muscles to like move or like put pressure on bivalves, for example. So sea stars, very cool, or echinoderms rather. So, echinoderms, when they reproduce, they typically are doing broadcast spawning. So, like, here's a sea urchin releasing some sperm into the water. So, they typically release sperm and eggs out into the water. Though there are a few species of like sea star that will brood their young. So, here, this is like the arm of a sea star, and you can see all these teeny tiny little baby sea stars like attached to its arm. So, it is brooding its young here. But most echinoderms do broadcast spawning. Um, then once they, of course, broadcast spawn, hopefully the sperm and egg meet up together, then they develop into a few different types of planktonic larvae. So a crinoid will have a doliolaria larva that looks like this. Ophiuroids, the brittle stars will have one that looks like this. The echinoids will have one that looks kind of like this. The sea stars will have a bipinnaria larva that looks like this. So a few different types of larvae in the different echinoderm families. But again, like so many of these marine invertebrate groups, they start out as part of the plankton and then later are, in this case, most of them are benthic. Pretty much all of them are benthic as adults. Another cool thing about echinoderms is that echinoderms are super good at regeneration. So they're able to regenerate huge portions of their body. So, if you take a sea star, you can actually cut it into several pieces. And as long as that piece contains part of the central disc area, so like this middle area here, it can basically regrow the rest of its body. So instead of dying, it just like regrows that body. So you can see in both of these cases, the sea star is regrowing its arms. So this one's here, you've got three arms, and then four or five are regrowing here. Some mistakes get made. And so, like in this one here, you've got three arms, and then it's actually growing another three arms. So instead of regrowing two, it's regrowing three. And so that's how you can sometimes end up with sea stars that have like six arms because they lost an arm, but then accidentally like grew back two instead of one. And now they can also use this regeneration to reproduce asexually. Because if you take a sea star and cut it in half, both halves will regrow like the rest, and you'll now have two sea stars. So they're so good at regeneration, they can use it to reproduce asexually, which is pretty crazy. Next up, we're going to talk about some of the classes contained inside of phylum Echinodermata. First, class Asteroidea. So asteroid, right? This is basically saying that they are star shaped. So these are our sea stars. So asteroid, sea star, star, sea star. So asteroidea sea stars, they have five or sometimes more arms that radiate from a central disk. So you have the central disk area and the arms coming off. It's usually five, but in the case of like sunflower stars, I'll talk about in a moment, they have more. On the what we call the oral surface. So the oral surface is on like the what we can kind of consider the bottom. That's where the mouth is, and then the top has the anus, the madreporite, and often a lot of these small what we call pedic. Let me see. Pedicellariae, I believe. It's been a while since I've heard that word out loud. But basically these tiny little kind of pincher structures that they can actually like move and articulate, and they use these to keep their surface clean. So they'll like pick off pieces of algae, or like if like maybe like a barnacle tries to settle on them, they'll kick that little larva off of themselves. So they will keep their this surface here clean with these little pincher structures. The vast majority of sea stars are predators. And in fact, if you are something that can't move quickly, they are terrifying predators. They're just like these like murder bots of the ocean for things like bivalves that don't move around very fast. And so we talked about how they're really good hunting bivalves because they can use that water vascular system to use water pressure and pry these bivalves open. But once they do that, the nightmares don't stop there for the bivalve because the way that sea stars eat is by everting their stomach. What that means is they basically throw up their own stomach out of their mouth, and they will actually like say they've pried open that bivalve shell a little bit, like a little crack. They'll basically just like throw up their stomach and push their stomach in through that crack and digest like the mussel or the clam or whatever it is, and then suck their stomach back in through their mouth. Um, and so this is pretty crazy that to vomit up your, instead of bringing food to your stomach, what if you brought the stomach to the food? That's basically what these guys do. They evert their stomach to eat. You can sometimes see this at like an aquarium if there are sea stars attached to the glass. Sometimes you'll see them feeding. They'll have their little stomach out like this. This is another like a leather star here, a bat star, where you can see it's eating some fish. This sea star is having a great day. This is like a big old nice meal of food, but you can kind of see it's like webby stuff around the fish. That is the sea star's stomach where it's digesting these fish. So that's how sea stars eat, by barfing up their own stomach. My really cool example of a class of an asteroidean is the sunflower sea star. These guys have 16 to 24 arms. They come in a bunch of different colors. They are relatively fast. They can move, oh, what was it? I want to say like 3 inches a minute, or it might have been like more like 3 feet a minute. I think that's actually what it is. I think it's 3 feet a minute. So for sea stars, they're pretty speedy. They eat a lot of different kelp herbivores, so things like sea urchins, snails, things that eat kelp. So they're often they can be a keystone species, similar to sea otters in a kelp forest, because just like sea otters, they're eating those kelp herbivores and helping to keep their populations in check. Unfortunately, sea stars are now considered, sorry, sunflower stars are now considered critically endangered. There are very few of them left. Their populations have declined by anywhere from like 80 to 100%, depending on where we're talking about. The main reasons for this are unfortunately ocean warming, so they don't do well when the water warms up. And kind of in conjunction with that, there was this disease that in the past, and I think still to this day, is going through them, called sea star wasting disease. It was crazy because they'd get infected by this. We eventually learned it's a bacteria that does this. They'd get infected by this bacteria and they would almost like rot. Like they would just kind of fall apart and their arms would fall off and they would just almost like dissolve. It was crazy. Um, and so between the warmer water and this bacterial disease, again, their populations have severely declined. But there are some like breeding programs and things like that that are trying to help to reestablish their populations. But very cool sea star example. All right, so that was class Asteroidea. Next up, class Ophiuroidea, or Ophiuridae. And these are brittle stars. So they look a lot like sea stars in that they have this like central disk area, but their arms are much longer and thinner relative to that part of their body. Um, their 2 feet also lack suckers, so the 2 feet are kind of just almost more like tentacles, like they don't have a little sucker at the end. And their organs don't extend into their arms. So for sea stars, let me actually go back a few, I can show it in this. You can see that their arms, each of their arms has like digestive glands and gonads inside of it, and of course, like the water vascular protrusions, whereas the brittle stars, the Ophiurides, will have the water vascular system, but not any like digestive structures or gonads or anything like that. Those will just be in the central disc area. Rather than predators, most of these guys are detritivores, meaning that they are eating like dead stuff, essentially. And some of them are also kind of filter feeders. This is called a basket star. I love them. I think they're really pretty. And they use these kind of branching arms to capture stuff out of the water and then eat it. Next class, Echinoidea. Chine means like spike. So echinoderm actually means like spiky skin. And then echinidae, sorry, I say dea, it's D. Echinidae, they are extra spiky because these are the sea urchins and also the sand dollars who have smaller spines, but still spines. Um, they, of course, instead of having 5 arms that extend out from their body, have a very round and test, is what we call it, this structure, this rounded structure here. And instead of like moving with arms, they instead have these spines that they can actually move, like and articulate. So each of the spine is basically in like a little ball and socket joint, and they can move the spines around and articulate them in different directions. And they mostly use these to move, although they do have 2 feet with suckers as well. Um, so no arms. They have this cool feeding apparatus down at the bottom here. So again, their mouth is located kind of on the bottom of their body, just like a sea star. But they have, rather than averting their stomach, they are grazers, meaning they're mostly scraping up like algae or eating things like seaweed. And they have this very cool structure here called Aristotle's lantern. That's a series of calcareous plates and muscles that kind of acts like a weird little, almost like alien feeding structure on the inside of their bodies that they use to scrape up or bite into pieces algae. So that is echinoids. They have no arms and they have that cool Aristotle lantern feeding apparatus. So, next question for you guys. Sea stars look pretty different than starfish when you like hold the two next to each other. So, thinking back to what makes an echinoderm, how do we know that they are in the phylum Echinodermata with starfish? How do we know what are the structures these guys have in common so that we know they're like closely related to each other? That they both belong in the same phylum.